Good afternoon, everybody. This is Dr. Murli Bharadwaj, your teacher in physics. To become a doctor, you should be good in physics. That is the whole challenge, right? Now, let us make the physics very interesting, very easy, very logical, provided you know few basics. अच्छा बच्चों, हम Coulomb's law के बारे में बात करेंगे. What is Coulomb's law? Coulomb's law is the one which said that when there are two charges, Q1, Q2, there can be certain amount of attraction. Suppose if Q1 is negative charge, Q2 is positive charge, there can be attraction. If the Q1 is positive, Q2 is also positive, क्या होता है बच्चों? There is a repulsion. Now, the Coulomb's law is the one which says when there are two charges, Q1, Q2, separated by a distance of r, what will be the magnitude and the vector of the force between these two charges? यहाँ Q1 है, let us say it is a positive charge. यहाँ Q2 है, this is a positive charge. So Q1 repels Q2 in this direction, whereas Q2 repels Q1 in this direction. So whenever it is repelling means it is saying, go away from me. That is called repulsion. So there is certain force with which this repulsion occurs when the Q1 is repelling the Q2. इस फोर्स का वेक्टर को हम लिखते हैं F21. ऐसे क्यों लिखते हैं हम F21? It is the Q2 which is getting repelled. And who is repelling it? It is the Q1 which is repelling. इसलिए इसका रिप्रेजेंटेशन होता है F21, that is 2 is getting repelled away from the Q1. Similarly, if you look at the repulsion that occur on the Q1 by the Q2, where Q1 is asked to get out. So who is asked to get out? Q1. By whom? By Q2. इसलिए इस फोर्स को रिप्रेजेंट करते हैं F12, the vector F12. So what Coulomb's law says is, typically this F12 vector is equal to the F21, the magnitude is equal. So how do you represent the magnitude of a vector? By the modulus. So the magnitude F12 will be equal to the magnitude of F21. So that is what you should understand. Suppose if Q1 is positive, Q2 is negative, then the F12, the magnitude with which the attraction occurs, Q1 attracts Q2, and F21, where the Q2 is attracted by the Q1, the magnitude will be equal, is what you have to understand. Now, how will be that magnitude of that vector F? That will be directly proportional to the product of Q1 and Q2. That is Q1 into Q2. The force is proportional to Q1 into Q2 is what you need to remember. Then that force is inversely proportional to the square of the distance between the Q1 and Q2. That is, F is proportional to 1 by R square. So F is equal to K into Q1 by Q2 by R square. इसको कहते हैं Coulomb's law. Now, how are these Q1 and Q2? Are they separated from each other by air or by vacuum or by fluid? What is the medium? Even that will decide the force of attraction and repulsion between them. So F also depends on medium that is separating Q1 and the Q2 is what you should remember. Now, this K is a constant, and you should remember it depends on the medium between Q1 and Q2 is what you should remember. Then what is the third point about the Coulomb's law? This force which is acting between Q1 and Q2, this force, it acts along the line which is joining the center of these two charges. ये दोनों charges को join करते हुए line है ना, A line, the force acts along the line is what you have to remember. That is the third point of the Coulomb's law. Now, what is the value of the K? You should remember K is equal to 1 by 4 pi epsilon. Epsilon को क्या बोलते हैं? Permittivity. It's called permittivity. And it depends upon the medium which is there between Q1 and Q2. So K is equal to 1 by 4 pi epsilon is what you should remember. So this is the Coulomb's law. Very simple law hai. It is defining the force of attraction or repulsion between two charges Q1 and Q2 which are separated by a distance of r. Now, what is the value of this K? What is the value of K? It is 9 into 10 to the power of 9 Newton meter square by Coulomb square. How did you get that? K, this value K is equal to F into R square. F को, what is the unit of force? Newton. R square ऊपर जाएगा. So that is meter square divided by this Q1 and Q2 will come down. So that is Q1 is charge is Coulomb. So Q1 into Q2 is Coulomb square. So that comes into denominator. So if you write K is equal to F into R square divided by Q1 into Q2. So that is the reason you should remember F, the force is Newton, R square is meter square divided by Q1 into Q2 ho gaya Coulomb square. So that is the K, which is the constant, and constant depends on medium which is separating Q1 and Q2 is what you should remember. Achha. Now, you all know this very important law. So, F is proportional to 1 by R square. यहाँ क्या हो गया Coulomb's law में? The force is inversely proportional to R square. इसलिए इसको क्या कहते हैं? Inverse square law. Inverse square law. अगर आप y axis के ऊपर F लिए, force को लिया, you have taken the force on the y axis. You have taken R, the distance separating them in the x axis. Then typically the graph will be like this. So that is force is proportional to 1 by R square is what you should remember. That means if you happen to double the distance, then what happened? The force has become 1/4. Original force ka 1/4 ho gaya. If you double, this became 2 into 2. So F is proportional to 1 by 4 R square. So the new F is equal to F by 4. So if the distance is halved, you have halved it, then the force between the two charges has increased to 4F. So F is proportional to 1 by R square को कहते हैं inverse square law is what you should remember. Now a very important discussion. Write the vector form of the Coulomb's law. Now let us look the forces as vectors rather than just their magnitude. So here you have the Q1, here you have the Q2, and the Q2 is being pushed away by Q1, इसलिए इसको कहते हैं F21. Q1 is pushed away by the Q2, That is the reason we call this as F12. You understood, right? And the distance between the two is R modulus. R modulus. Then how will you represent the vector? Very simple. The vector, that is a force of repulsion, this F21's vector, the Q1 is pushing the Q2 away. So typically the distance as a vector is what? Displacement. Displacement. So you should remember, displacement is a vectorial form of the distance, which is the scalar, which is the magnitude of the displacement. So displacement is what? The final distance minus initial distance. So इसलिए this should be R2 minus R1 is the displacement when the Q1 is repelling the Q2 in this direction. Similarly, what will be the displacement when the Q2 is pushing the Q1 away? It should be written as the final displacement is R1 minus R2 is the magnitude when we are talking about the displacement of Q1 because of the repulsion caused by Q2 is what you should remember. Now, let us look at the F12. How will you get F12? F12 is equal to K into Q1 Q2 by Q1 Q2 by R modulus square. That means the magnitude of the distance between Q1 and Q2 is R modulus square. Always a vectorial representation में magnitude होता है और एक direction होता है. Magnitude होता है और एक direction होता है. So how do you represent the direction? R1 minus R2. The vectorial form R1 minus R2. Now we have studied in the unit vector. In the unit vector, how do you get the unit vector value? The A represented by unit vector like this is equal to the A, the vectorial form divided by the magnitude of the A. So here, how can you represent? How can you represent this as a unit vector? So you can represent that as a unit vector. So always when you are writing in a vectorial form, you should remember there's a magnitude. This part is all magnitude, whereas this part is all direction. It is talking about the direction. Now F12 is equal to the vector F12 is equal to K Q1 Q2 by R modulus square. R modulus square, same as it is. Now you represent this as a vector. How will you represent this as a unit vector? R1 minus R2. The direction is what? For the F12. For the F12, the direction is R1 minus R2. F12 कैसे जा रहे हैं? ऐसे जा रहे हैं. So final displacement is R1. Initial displacement is R2. इसलिए the displacement between Q1 and Q2 is being defined as R1 minus R2 factorially represented divided by R1 minus R1 modulus minus R2 modulus is what you should remember. Now we have seen that R1 modulus minus R2 modulus is equal to R modulus. So यहाँ के R modulus है ना, so R1 minus R2 modulus is equal to R modulus. यहाँ देखा ना हम R1 minus R2 modulus is equal to R modulus. So if we represent that here, R modulus is equal to R1 minus R2 modulus. If you represent here, what do you get? K Q1 Q2 by R1 minus R2, R1 minus R2 whole square into R1 minus R2. Oh, that becomes R1 minus R2 whole cube. So K is equal, F12 is equal to K into Q1 Q2 by R1 minus R2 whole cube and R1 minus R2 in the numerator. So this is called the vectorial representation of the Coulomb's law is what you should remember. Now you also know how to write a similar way F21, how to represent it vectorially. Now you know that very well. Now let us talk about two important forces here. एक electrostatic force है. How do you get static electrostatic force का equation क्या है? FE is equal to K into Q1 Q2 by R square. You are sure about it, right? Now, how do you get a representation of gravitational force? In the first year we have studied, right? The force of gravity, FG, is equal to the gravitational constant G into the mass of object 1 into mass of object 2 divided by R square, the distance separating them. Are these two equations, are they looking similar? Very similar, very similar. The only difference is K, जो होता है यहाँ की K, this electrostatic constant, force constant, it is 9 into 10 to the power of 9 Newton meter square by Coulomb square. 10 to the power of 9, very big magnitude. Whereas the gravitational force, in that the gravitational constant, if you see, it is G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. So minus 11 is a small number, whereas 10 to the power of 9 is a big number. इसलिए the force of gravity, gravitational force between two objects will be very small. But if they are charged objects, if the two objects are charged ones, then the electrostatic force will be significantly larger compared to that of the gravitational force. That is what you need to understand. Barabar? Easy to follow? Very good. Now, what is the similarity between electrostatic force and gravitational force, bachon? Similarity, number one, both of them are obeying the inverse square law. Inverse square law क्या होता है? F is proportional to 1 by R square is called inverse square law. Then both the electrostatic force, gravitational force, both of them are acting along the lines which are joining their centers. Let us say you are having one mass. You have another ball here. This ball and this ball are having a, let us say, you have arranged it like this. So there is a gravitational force. Always the gravitational force will act connecting along the line joining the centers. So that is the second similarity. अच्छा भाई, difference क्या होता है? If you take the electrostatic force, और repel भी कर सकता, attract भी कर सकता. It can repel and also attract. Whereas gravitational force जो होता है, it is always attractive. That is the difference. Number two, the gravitational force जो होता है, it is independent of the medium between two balls. Whether the medium is water, air, vacuum, whatever it is independent of medium. Whereas electrostatic force जो होता है, it depends on the medium. The electrostatic constant, it is dependent on the medium. That is what you have to basically remember. Now, let us take up few important problems based upon what all that we have learned now. Abhi fatafat bolo bachcho. The law governing the force between electric charges is, what is that law? Tomorrow's NEET UG exam में यही क्वेश्चन पूछेगा, आपका आंसर होता है Coulomb's law. Now, let us take up one problem. Two equal point charges, equal है दोनों charges. इसका charge कितना है? 3 microcoulomb. And they are separated by certain distance. which is being given in meters. And suppose if they are located at I plus j plus k is the vectorial representation of the position of one charge. So typically you will take the y-axis, x-axis, z-axis, and any vector is being represented in these three axes, right? So I plus j plus k, and the other is located at 2i plus 3j plus 3k. That is the position of the second charge. So एक चार्ज यहाँ है और दूसरा चार्ज यहाँ है. इसका पोजीशन I plus j plus k और इसका पोजीशन 2i plus 3j plus 3k, right? Now, what is examiner asking? Then the electrostatic force between these two charges कितना होता है? What will be the electrostatic force between these two charges? It's very simple. Q1 is being given as 3 microcoulomb. Micro होता है 10 to the power of minus 6. So 3 into 10 to the power of minus 6 coulomb. Q2 is also equal to Q1. That is also 3 microcoulombs. That is 3 into 10 to the power of minus 6 coulombs. Barabar? Now, the distance between the two charges R is equal to R2 minus R1. Already we discussed now that whenever you have one charge, say you call Q1, and you have another charge called Q2, and let us say we are talking about a force that is F21. So that means Q1 is repelling the Q2. So Q2 is the one which has got repelled. So F21 is the representation. And displacement hota hai R2, the final displacement, minus the initial displacement, R1, R2 minus R1. So that is equal to 2i minus 3j plus 3k. Examiner ने already दे दिया इसको. And R1 i plus j plus k. So 2 minus 1, 1 i, 3 minus 1, 2, 2j, plus 3 minus 1, 2, 2k. So I plus 2j plus 2k. So the magnitude of this vector I plus 2j plus 2k, the magnitude is equal to square root of इसका I के सामने क्या है 1, so 1 square. J के सामने क्या है 2 square, plus k, before k you have 2 square. So 2 to the 4 plus 2 to the 4 8 plus 1 9, square root of 9 is equal to 3. So the distance has become 3 meters. That's what you need to basically remember. Now, according to the Coulomb's law, Coulomb's law में force को calculate करने के लिए what do you require? 1 by 4 pi epsilon O Q1 into Q2 divided by R square. R का magnitude मिल गया क्या? हाँ मिल गया 3, right? Q1 already वो दे दिया 3 into 10 to the power of minus 6 into 3 into 10 to the power of minus 6. And 1 by 4 pi epsilon मालूम है क्या आपको? मालूम है 9 into 10 to the power of 9. So 9 into 10 to the power of 9 into 3 into 10 to the power of minus 6 into 3 into 10 to the power of minus 6 divided by 3 square. That is equal to 9 into 10 to the power of minus 3 newtons is the answer. Very easy, right? So you should know how to represent the vectors, how to subtract a vector from another vector. That's all. That is the only secret about this particular question. Now, let us take up the next question. Find the ratio of electric force, electrostatic force to that of the gravitational force for 2 electrons. Yeah, who is the point charge? 2 electrons. They are placed at some distance apart. So to solve this, you should know some standard values. Please don't forget, keep one 200 pages notebook. In that, certain values that you need to remember, you need to write it and then discuss with your classmates to remember it forever. So the charge on the electron is equal to minus 1.6 into 10 to the power of minus 19 Coulomb. हम भूलेंगे नहीं. Mass of electron is equal to 9 into 10 to the power of minus 31 kg. We are not going to forget, Papa. K is equal to 9 into 10 to the power of 9 Newton meter square divided by Coulomb square. And what is the gravitational constant? 6.67 into 10 to the power of minus 11 Newton meter square per kg square. अगर ये values भूल गए तो it is like the warrior Karna forgetting the mantra in the battlefield. That is the reason you need to remember it. Perfectly remember it. Badhiya. Now, let us calculate what is our challenge given by the examiner. Electrostatic force by gravitational force ka ratio he is asking us to discover. Electrostatic force is equal to K into Q1 Q2 by R square. Gravitational force is G into M1 M2 by R square. R square common ho gaya. So electrostatic force by gravitational force is equal to K divided by G. Q1 Q2 comes into numerator. क्यों? Electrostatic force numerator में है ना. So divided by M1 M2 ये denominator में आएगा क्योंकि the gravitational force is in the denominator, and that is equal to K into Q square divided by G into M square. G into M square. So Fe by Fg is equal to 9 into 10 to the power of 9, which is the K value. Q1 into Q2 is 1.6 into 10 to the power of minus 19 electron का charge whole square divided by G, 6.67 into 10 to the power of minus 11 into 9 into 10 to the power of minus 31 square, which is the mass of the electron, and that will be equal to around 10 to the power of 42. That means the electrostatic force between two electrons is almost 10 to the power of 42 times higher than that of the gravitational force between two electrons. Far higher is what you have to remember. So this is how you have to learn the theory, apply the formula, and then the physics become a joy with Dr. Murli Bharadwaj. Thanks for a patient listening.